All right, this is chapter 3A quiz. I have vectors A and B. I want to know the result of the difference between A minus B. So if I draw my vector A, it looks like this. The negative of B is going to look like this. So this is A, this is minus B. And then if I add those two together, I draw them like that, I have A minus B. So that is going to be D. If vector A has a magnitude of 12 meters and vector B has a magnitude of 25 meters, which of these is a possible solution for the sum A plus B? All right, so I can have two scenarios in here. I can have the vector A and the vector B in the same direction. That's going to be 12 and 25, which gives me a net vector of 37. Or I can have 12 in this direction, 25 in this direction, and that's going to give me a net vector of 25 minus 12, or 13. Those are the max and mins for these vectors. It has to be between a magnitude of 13 and 37, so the only of those is C, 32. Two vectors are given such that A plus B equals 0. What can you say about the magnitude and direction of vectors A plus B? In order for A plus B to equal 0, you have to have one vector in one direction and another vector in another direction, and they have to have equal magnitude. So same magnitude, but opposite directions. That is D. Given that A plus B equals C, and the magnitude of A squared plus B squared is C squared, how are vectors A and B oriented? All right, this should look familiar to you. This is the Pythagorean Theorem. So based on that, I can say then that my vectors A and B have to be arranged like this, like a right triangle. Given that A plus B equals C, and the magnitude of A plus the magnitude of B equals C, how are vectors A plus B oriented with respect to each one another? In order for this to be true, they have to be parallel and in the same direction. Let me show you. Let's say that I have a vector A let's say that I have a vector A right here and a vector B. I'm going to draw it perpendicular like this, B right here. Then the vector C will be like this. Now C, the magnitude of C is going to be less than the sum of magnitudes A plus B, because the distance going from here to here is shorter than the distance going there. All right, so the only way for A plus B equals C and the magnitude of A plus B equals C has to be like this, where I have A and B in the same direction and C looks like that. So the vector sum is equal to the sum, or is identical to the sum of the magnitudes. So that is B is the answer. If each component of a vector is doubled, what happens to the angle of that vector? If each component is doubled, nothing happens to the angle. All right, imagine I have a right triangle like this. All right, if I change the size of that triangle, these angles are going to remain the same, as long as I change both sides the same way. So the answer is C for this one. A certain vector has x and y components that are equal in magnitude. What of the following is a possible angle for this vector? So equal x and y components. So this is my x component, this is my y component. If those two are equal, this angle has to be 45 degrees. That's an equilateral right triangle. That's E. You are adding vectors of length 20 and 40 units. What's the only possible resultant magnitude? I think we've had one like this already. You can have 20 and 40, or you can have 20 and 40. This gives you a max of 60, and this gives you a min of 20 units. So somewhere between 20 and 60 And looks like that's C.